This is 8.2 for statistics class, and we are going to be talking about counting and probability. So we start studying probability because of gambling, basically. We want to be able to know the probability that you are going to win or lose something, so we're going to be doing some probability. Game shows rely on probability to tell you how much a contestant could win, and so how much advertising money they would need in order to pay those people. Casinos use it. Insurance companies use it too. They basically decide how likely you are to get in an accident or get sick or whatever their insurance company covers, and then they use that to decide how much they should charge their premiums. And weather forecasters also use probability because they tell you what's the chance of you using or getting rain or snow or whatever it is. So we're going to start very basic first of all. The first thing is counting methods. So whenever you have letters or numbers that can be repeated, like a web address, you could do www.aaa if you wanted. We can use something called a counting method. For an example, a website with only 2 letters or numbers in an address. So there are 26 letters in the alphabet, and there are 10 unique numbers because 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's 10 different numbers, equals 36 possible combinations, or not combinations, 36 possible total choices to choose from. So if I wanted to know how many possible combinations of letters, numbers, letters and numbers, just letters, just numbers, I would just do 36 times 36. And the reason why I do 36 times 36 is because the first time I choose a letter, there are 36 choices. And the second time, because I could use the same letter twice, it could be aa.com, I still have 36 letters I'm choosing from. So then we stick that in our calculator and we find out that there's 1,296 choices that I could have if my website was only 2 letters long. And we know that most websites are not 2 letters long because then you have more unique combinations. So the multiplication counting principle basically says that anytime you have multiple steps and you are allowed to use the same option over and over and over again, you're just going to multiply the number of possibilities that many times. Okay? This could be varied a little bit. If I wanted 1 letter and 1 number, this time I wouldn't do 36 times 36 because this gives me the option of letters or numbers, and this one gives me the option of letters or numbers. I would go to 1 letter. Well, there's 26 options there. And 1 number. There's 10 options there. And so I would only get 260 options. And it's more restrictive, obviously. There's only fewer to choose from because I'm being more picky. I want 1 letter and I want 1 number. But that's basically how the multiplication principle works. It's very, very easy. Whatever your options are, how many there are, you just multiply them together. And everybody loves ice cream, so let's use an example of ice cream. So if you have an ice cream shop and they advertise having 28 flavors, 11 different toppings, and 3 sizes for bowls, like maybe small, medium, large. So you're going to want to order 1 scoop with 1 topping. How many choices could you choose? Okay, so we're going to combine all of those different things using the multiplication principle. So because I want 1 scoop, there are 28 choices. And because I want 1 topping, well, looking at my toppings, I have 11 of those. So I'm going to times it by 11. And even though it didn't say, I have to choose what size I want. Do I want the small, the medium, or the large? And so I'm going to pick 1 size because I obviously have to pick what size I'm going to order. And there are 3 of those. So the multiplication principle says that if I take each one of these and multiply them together, that'll tell me how many choices I could make. And that is 924 choices. So if you've ever been to Sonic, on their drive-through the ordering places, they tell you like how many flavors of drinks you can order because they have so many flavors of drinks that you can do. Well, basically what they did is they took all of their soda flavors, like Coke or Sprite or whatever drinks they have, Dr. Pepper. And then, so they multiplied that number by how many flavors they have. So I think they had like a blueberry mix-in or a cherry mix-in or a coconut mix-in or all these weird mix-ins that you can choose. And they multiply them together. And then they think, well, maybe you don't want just one flavor. Maybe you want 2 flavors. And so all of these values get added up together, multiplied together using the multiplication principle. And so Sonic then can advertise, oh, we have over 1 million flavors or whatever. They don't have 1 million different drinks sitting there. It's just the way that you can combine them. And of course, some of the flavors people would never ever order, because you're probably not going to order a Coke with every single flavor mixed in, because that probably would be gross. But I don't know. Maybe it's good. So that is the multiplication principle. Okay, so the chair example. So if I had 5 chairs in the front of the class and I picked 5 of you to come and sit in them. So we have 5 chairs. One, two, three, four, 5. There we go. So we have 5 people who are going to be sitting in these chairs. So let's say that Liam is going to choose a chair. And let's say Naya's going to choose one. And Rachel can choose one. And Shamir can choose one. And I need one more person. Who else is in this class? Jalen. He can pick one. All right, so Liam is going to choose first. And there are 5 chairs that he can choose. And Liam loves to be the center of attention, so Liam picks this choice right here. But before he picked, Liam had 5 choices to choose from. So Liam's sitting front and center, and that's where he's sitting. And now Naya walks in, and she is going to choose one. And so Naya is looking at the chairs, and she decides not to sit on Liam's lap. So that means there are 1, 2, 3, 4 chairs left. So Naya's going to pick one, and maybe Naya sits over here. And then Rachel comes in, and Rachel also does not want to sit on Naya or Liam. So there are 3 chairs left for her to choose from, and she decides to sit right here. Shamir, also not wanting to sit on any of their heads, picks another seat. Before he did, there were only 2 chairs left. And Jalen walks in last. And unfortunately for Jalen, he really doesn't have much of a choice unless he wants to sit on somebody's head. So Jalen picks this last chair right here. So he had 1 chair to choose from. So in our chair example, it's kind of like the counting principle, only things can get used up. So now, once Liam picks a chair, there are only 4 choices for Naya, 3 choices for Rachel, 2 for Shamir, and 1 for Jalen. So this kind of counting principle takes into account that perhaps something could be used up. So when we're doing letters in a website, like you could have www.www if you wanted. Letters can repeat. But in this example, once a chair is used up and somebody's sitting in it, we don't want somebody else sitting in it too. We don't have 2 people sitting in a chair. So it gets used up. So once we do that, we get 120. And so this is just another way that we can use the counting principle. And actually it introduced a new term. So this term is called factorial. And factorial is the exclamation point sign. And you may have seen it before in mathematics. And it basically means that we are going to take every number from that number that you were given down and multiply them all together. So another way to write this 5 times 4 times 3 times 2 times 1, because that gets very lengthy, is to write 5 factorial. And your calculator should have a factorial button. And so you might want to look up on a Google search how to get to your factorial button if you don't know how, because we're going to be using that a lot. So anytime we say that factorial, that 5 exclamation point, what we really mean is 5 times 4 times 3 times 2 times 1. You can do this with any number you want. So 3 factorial is really 3 times 2 times 1, which is 6. And we stop at 1, obviously, because if we went down to 0, anything times 0 would be 0, and that would be a really pointless mathematic operation. But whatever number is in front of the exclamation point, that's the starting point, and then we stop at 1. So hopefully that's clear. So factorial is the product of the first number and all the numbers decreasing by 1 until we reach 1. And the mathematical symbol is in factorial. And we write that as n minus 1, n minus 2, blah, 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 3, 2, 1. Okay, so that is factorial. And that is going to be useful with our multiplication principle if we can use things up. All right, let's try a license plate example. So on a certain year, New Jersey license plates were 6 characters. The first 3 characters must be letters. The next 2 characters have to be numbers. And the last character is a letter. How many different possible license plates could there be that year? And let's go ahead and say that the letters could repeat. So maybe your license plate could be AAA 111A. That's possible to be an option. So take a second and write down the choices and use your calculator and see if you can come up with the answer. All right, so let's set this up. If the first 3 characters are letters, there were 26 letters in the alphabet, and they can repeat, so we're not counting down or anything. The next 2 letters are numbers, and remember we talked already that there are 10 unique numbers. So that represents our 2 middle numbers. And then I can pick one more letter for my last one. So that is our problem. We're going to do 26 times 26 times 26 times 10 times 10 times 26. So there should be 1, 2, 3, 4, 5, 6 numbers that we're multiplying. And we get a very large number. All right, so 45,697,600 possible license plate combinations. Of course, if we could make more less stipulations on it, like maybe it could be all letters or it could be all numbers, we would get even more. So in New Jersey, if there were less than 45 million drivers, they each would have a unique license plate, and which is very important for them to have unique license plates because you don't want to get a ticket that somebody else earned. So that is how many possible license plates they could issue in that particular year. Okay, so now we're going to get into something called permutations. And permutations is a command on most calculators. So you once again, if you don't know how to use the permutation button on your calculator, you want to do a Google search. Make sure you use the brand name of your calculator and ask about permutations. And sometimes there's even YouTube videos that show you how to do it with your particular calculator. You will need a calculator for this chapter and for this test, and it needs to have the ability to do factorials, permutations, and combinations, which we will get to. If you don't have one, you need to make a new best friend and borrow it from them, or go to Walmart and just buy one, because the cheaper ones are only about $15 or $20 that have those commands. But make sure you do look for it before you purchase it. Okay? So permutations are when order matters in a certain arrangement. So we have some different things that we're going to be using. The symbols, I'm going to write on the board because I have it typed there, obviously, but it's kind of hard to see what's going on. Those are sub letters right there. So that N and that K is kind of below the line. And we know that factorial means everything underneath that's going to get multiplied together. And we have N minus K factorial. We have to do order of operations. That means I need to subtract first, and whatever this answer is, then I take the factorial. So P stands for permutation because that's the name of the command. N is your number of choices. So if you are choosing out of 10 people, then obviously N is 10. And K is the number you will select. So out of those 10 people, if I'm only going to pick 3 people, then K would be my 3 value. And something we didn't talk about earlier, if you ever get a 0 factorial, that answer is not 0, by definition, it is 1. So just kind of keep that in mind. Okay, so there's our formula. Let's keep that in mind. So on our example, we have a class of 20 students, and we want to elect president, vice president, and treasurer. We want to know how many ways we could possibly choose these officers. And keep in mind that because president, vice president, and treasurer are different jobs, then our order matters, because whoever I pick first, if they're president, that's different than if I pick third and you're the treasurer. So we're going to do a permutation formula. So what we're actually doing is 20p3, and our first number, n, gets replaced here, and so we have 20 factorial, and then we do 20 minus 3 factorial, and we simplify. 20 factorial is really over 17 factorial. And there's a little trick with permutations, because you're counting down, blah, 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 1. And this one is also counting down, blah, 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 1. With these fractions, you can cancel. So obviously the 17 is going to cancel with the 17, the 16 is going to cancel with 16, 15 is going to cancel with 15, all the way down through 1. So in permutations, this always works out. Whichever is on bottom, the denominator actually ends up going away, because you have to cancel with what was up here. Okay, so really this problem is only asking what is 20 times 19 times 18. And that's easy enough to do on your calculator. So you just multiply those three numbers together, and we get 6,840 ways. If you have a permutation button, say like on the TI-84, I'll walk you through a TI-84 because that's the calculator I had and what I asked you to get at the beginning of the year. So what you would do on your TI-84, you would hit 20, and then you would go to math, and if you look at the top, you can scroll over to something that says PRB, and option number 2 says something like NPR, so you hit that and you hit enter. And then you type in your last number, which was 3. And then you hit enter, or the equal sign. And you will see that it also gives you 6,840. And then you don't have to plug in this whole formula and work it out. Like calculator does it straight for you using these commands. So once again, you type the number, go to math, scroll over to PRB. Option number 2 for a permutation, type in the number 3 and then hit enter, and it will do the whole thing for you without sticking it in the formula. So combinations are also something that we use factorials with, and combinations are when order does not matter. So in our example, when we had a treasurer and a president and a vice president, the order mattered because it mattered which one you got first. Another order mattered one is, say like I had a gift certificate for $50 to Amazon, and then a $30 gift certificate, and then a $10 gift certificate to Amazon. And I was going to pull names out of a hat to see who won it. Well, obviously the person who wins the $50 prize is getting a different prize than the 30 or the 10, and you would rather win the 50 if you're going to win something, although, you know, 10's not bad, 30's not bad, you'd rather have the 50. So that is another example where order matters, where we would use permutation. Combination is when order doesn't matter. So now if all I have are two $50 gift certificates and I'm going to pass them out to the first two people I pick, well then it doesn't matter if you're picked first or second, you still get the same prize. So hopefully that kind of makes sense. You have two prizes that are the same, you're going to use a combination. Or if I'm going to hire 3 people who are all going to be cashiers at Taco Bell, it doesn't matter if I hire you first, second, or third, you're going to have the same job. And so once again, order doesn't matter. I would use combinations. Now the combination formula is different than permutation, which you would expect because they're different things. We still use N and K, and they're lower letters like that. But the C is going to stand for combination. So P is permutation, C is combination. That's how we can kind of keep it straight. You are going to find NPK still, but you're going to take that answer and divide it by K factorial. Another way to think about that formula is just to combine those two. So remember that in NPK was N factorial over N minus K factorial. And I just slap that K factorial in front of it, and we get a new formula. This is for NCK. N is still going to be how many people you're choosing from. So if I had 10 people in a class, that goes there. And the K is still how many I'm choosing. So say 2 people get a gift certificate, then that's going to be a 2, that's going to be a 2. All right, so now I have my 20 students still, but now I'm going to choose 5 for student council. And student council doesn't have a specific job. They just all 5 meet. Nobody's in charge. Nobody's the low man on the totem pole. They're just all going to gather around like a round table session and discuss policies and decide, what the theme for prom is, all that happy stuff. So since there's no officers and all the people are equal, it does not matter how I choose them. So I need to do combination, because combination is when order does not matter. So we are doing 20C5. And so once again, 20 is going to be my N over my K, which is 5 factorial, and then 20 minus 5. 20 factorial over 5 factorial, and 20 minus 5 is 15 factorial. So we're getting a lot of factorials going on here. All right, so 20 we know is going to count down like this. And we go all the way down to 1. 5 factorial goes 5, 4, 3, 2, 1. And 15 goes down to 1 as well. The 15 through 1 and the 15 through 1 cancel. And then you could get a little bit tricky, like 5 times 4 is 20, so maybe I'll cancel those off. And so then I would just really be multiplying these 3 or 4 numbers together. And we're going to divide it by 3 times 2 times 1, which is really 6. And when I do that, I get that there's 15,504 ways that I could choose my student council. Once again, as you could guess, you can do this on your calculator. So if I were to do this problem on my calculator on the TI, I would hit 20. I would go to the math button, go back to the PRB, and this one is option number 3 for me, or it is the NCR button. So I hit that, and then I tell it to do 5, and then I tell it to do enter, and it will tell you the answer, the 15,504, without having to do, once again, all of this. So you basically skip all of these steps if you just do the calculator steps. And it is a lot to type in, so definitely write it down in your notes, especially if you have a TI-84. If you don't have a TI-84, it might be easier on some other brands. I know some other brands you just type 20 and then you hit the PRB button, and then, or the NCR button, I'm sorry, and then you hit 5 and then it tells you your answer. All right, so we can do expected value with this, and we talked about expected value in the last section. Expected value is just the average that you're expecting to pay. So let's say that you're going to play a lottery, and you pay $1 for your ticket, and you're going to choose 3-digit numbers. So 123 or 369 or 925 or something like that. And the state will choose a 3-digit winning number at random, and it will pay you $500 if your winning number was chosen. And if your winning number is not chosen, you just lost your dollar. So what's your chance of winning, and how much of your dollar does the state keep in the long run? All right, so there's a couple of steps to this. First of all, to figure out how likely it is to win, we have to say, well, there's 10 numbers, and I can pick 3 numbers. And they can repeat. My number could be 555. That's okay. So 10 times 10 times 10 is 1,000 choices. Only one winner based out of those 1,000 numbers. So your chance of winning should make sense that it's 1 out of 1,000. And if you win $500. So we take the $500 and we multiply it by the 1 over 1,000. And our chance of losing is really 999 out of 1,000, because our probability should always add up to 1. And when I do that, I win no money at all. So I would take 0 and multiply it by 999 over 1,000. So this ends up being 0.5, and this ends up being 0. And then we just add those two together. So 0.5 plus 0 is 0.5, or 50 cents. So if you played this in the long run over and over and over again every day for many years of your life, on average you could expect to win 50 cents, because sometimes you win the 500 and then lots more times you win nothing. So when you average it all out, it ends up that you kind of won 50 cents if you talk about how much money you paid and how much money you got back. So your ticket was $1. So if you're winning 50 cents, that means that the state is also winning 50 cents, because your money has to go somewhere. So 50 plus 50 is $1. So 50 cents per ticket is how much the state is making money on. So as you can see, if everybody who pays for a ticket, the state is winning 50 cents, then they're making a lot of money off this deal. And so that's how we do expected value. So if expected value, you take your probability times how much you're going to win, and your other probability and how much you're going to win. And you could probably do 3 of these, because maybe sometimes you win 500 and sometimes you win 100 and then sometimes you win 0. You multiply those together, and then you take all your answers and add them up, and that's how you get your expected value. So make sure you do write that down. Some of you are struggling with that. It's not too bad of a concept. All right, so I think I'm going to skip this question for now because our video is getting kind of long. But basically, now these permutations and combinations open up new ways to answer questions. So if I wanted to deal 2 cards from a shuffled deck, and I want to find the probability that I pick an ace on both times, I could do a tree diagram where we do an ace and a not an ace, and then an ace and not an ace again, and we multiply down the branches. Or we could just use permutation or combination. Order really doesn't matter if I'm drawing 2 aces, so I'd probably do combination. And that just gives us a new way to get solutions. Okay, so let's do one last example, I think. So we are going to try to answer our 28 flavor ice cream question again. So now we have 3 different scenarios that are going to have different answers, and we have to kind of read carefully so we know what on earth the question is asking for. So the first question says a cone with 2 scoops if you care about the order of flavors. This one is one where the flavors don't have to be different, because if you notice in the other examples, I say the flavors have to be different. All right, so if my flavors are different, and I don't care which, or the same, and I don't care which order, I'm just going to do 28 times 28. If I have, for B, a scoop with 2 scoops, and I want different flavors, and I care about the order, that's now a permutation. Okay? So it's a permutation, and I have 28 flavors, and I'm going to choose 2 of them. A cup with 2 different scoops of different flavors, and the order does not matter, is now a combination. Because combination, the order does not matter, but you use up flavors, right? So your answers would be, for this one, 784, if you did these on your calculator. This one would be 756, and this one would be 378. So take a second and pull up your formula for permutation and pull up your formula for combination and plug in those numbers. And make sure you are able to get these 2 numbers if you don't have a calculator that does that command. because the questions on your homework are going to be very heavily relying on these formulas, and so you want to make sure that you can practice right now where you have something where you can check your answers with. All right, and so there is your homework, and I will post this on Google Classroom. So please make sure that you've taken good notes on this, and you can review the video. If you still have any questions, obviously you can text that message board.